Hey y'all, my name is Shannon O'Shell, and today we're going to be discussing mitochondrial DNA in forensic investigation, and more specifically focusing on a case that dealt with cat hair. Autosomal STNR analysis is considered the gold standard because it provides high discriminatory power. However, STR testing requires nuclear DNA. In some evidence types, such as shed hair shafts, nuclear DNA is absent or too degraded. In these situations, mitochondrial DNA analysis becomes a valuable alternative. Mitochondrial DNA is found in the mitochondria rather than the nucleus. It is inherited solely from the mother. Each cell contains hundreds of thousands of copies of mitochondrial DNA, making it useful for degraded samples, such as hair shafts. However, mDNA cannot uniquely identify an individual because it reflects maternal lineage only. In March 2004, a homicide investigation in the Kansas City area involved a victim from whom a cat hair was recovered. The lining of the victim's pockets had been turned inside out. Hinge lifts were performed on the pocket lining and provided a single hair. Light microscopy discovered the hair was from a domestic cat. The suspect owned several cats. Investigators sought to determine whether the hair could be linked to the suspect's household. The recovered hair was a naturally shed hair without a root. The root is what contains most of the nuclear DNA required for STR testing. Because there was insufficient nuclear DNA, STR amplification failed, necessitating an alternative approach. Investigators extracted mitochondrial DNA from the hair shaft and sequenced the hypervariable regions. The sequence was compared to reference samples from the suspect's cats and the victim's cats. The victim's cats were excluded as a source of the hair. Although mitochondrial DNA cannot uniquely identify a single cat, it can exclude potential sources. The suspect's cats could not be excluded, linking the hair to the suspect's household and providing associative evidence that supported the prosecution. The sample was tested in 3 different labs for confirmatory results prior to being successful in court. The defense repeatedly challenged the admissibility of the cat mitochondrial evidence. The court evaluated the reliability of the methodology and determined that mitochondrial DNA sequencing was scientifically valid. The evidence was admitted and used in the criminal proceeding. It took several tries in court before being allowed to be utilized and help convict the suspect. Mitochondrial DNA analysis is useful for degraded samples because of its high copy number. However, it cannot uniquely identify an individual and reflects only maternal lineage, which limits its discriminatory power compared to STR analysis. This case demonstrates the importance of alternative DNA methods in forensic science. When STR analysis was not possible, mitochondrial DNA sequencing provided meaningful investigative value. It shows how forensic science adapts when traditional methods are insufficient.